All right, so I've been asked to do practice problems for question for chapter 12. So right now I am on question number 1 for chapter number 12. So let's go over this question and solve it. There's a company called Roundtree Manor. It's a hotel which provides two types of rooms with three rental classes: Super Saver, Deluxe, and Business. And they have given us a profit per night for each type of room and each rental class. So one thing we have to uh, think about it before going into this, that this is like 2 by 2 table. So there are two different types, type 1, type 2, and then there is a rental class. So there's the class, there are three different class. So total, we have 6 parameters technically. So we have how many? 6. So there are 6 possible combinations, like type 1 can take Super Saver, then type 1 can take Deluxe, type 1 can take Business. So most of the questions we have done in the homework, there isn't usually like this kind of combination. Here we can create types by each of the two um, parameters. Also, one thing we have to keep a note that type 1 does not have a business class. Only type 2 has a business class. So technically, there should be 5 parameters. There should be 5 different changing values, not 6. So we have to make a model which has 5 different parameters: x1, x2, x3, x4, and x5, not x6. So if we change the values of x1, x2, x3, these are the profits per night. So this is the profit per night and for one room. And we can give each type of room and the class of room in different levels. So we have to make sure that how many rooms are type 1. We cannot allocate or give rent too many rooms because there is a limit on type 1 and then also on the class of the room. But there are different profits and we want to maximize our profit. So the Roundtree management makes a forecast. So they are making a forecast of the demand by the rental class for each night in the future. A linear programming a model developed to maximize the profit is used to determine how many reservations to accept for each rental class. So they have to accept the reservations based on the forecast, and they know the forecasted demand for each night is for one kind Super Saver class. So for all these is 130. So the total they can go in this class is 130. So they can demand can be up to 130. And then there can be demand for they know they have forecasted that it will be 60 and 50. Since these are forecasted demands, Roundtree will take no more than these amounts of each reservation for each rental class. So for the rental class, they know the demand and they know their room types. Okay. And they know these numbers, so the demand cannot go above these numbers. They cannot have more demand for above these numbers. It will be always equal to or less than this number. Also, they know how many room types they have. They have type 100 rooms and type 2 120 rooms. Now we have to formulate a problem to determine how many reservations to accept in each rental class and how the reservation should be allocated on room types. We know the demand, so we can see how much we should accept, and we also know that we have limited room types, and we have to find these 6 different variables. So as I said, we will have 5 different, so it's not 6 because this is not this is not possible. So we only have 5 different options. So first thing we should do, we should try to write this problem as simply as we can. All right, so I think what we should do here is, before just jumping into the question, I want to make sure that I want to start my model and parameters from here. So the first thing I should make sure is this data table. Super Saver, Deluxe, and Business. Here we have type 1, type 2, sorry, it should be 40. All right, and then here we know how much demand we may expect. So I'll put demand here too. So I'm putting everything what I got into my table. So how much demand it is, demand for a particular night for Super Saver is so the demand for these kind of rentals is 130. For this one is 60, and for the another one is 50. And we also know the demand. So we know how much they are demanding for this, for each type. So we have to think about how much demand we have, and we have, how much, no, I'm sorry, this should not be demand. I'm sorry, I just made it wrong. Availability, because we know how many types of rooms we have available. So this should be 100 for type 1, and this is 120 for type number 2 from here. Now we should go into the model. Model, we can make, we can create a model here with, this is like, that was just, so this whole table is the parameters, or this is the demand, availability, and the cost, or not the cost, actually the profit. So this is the profit, this is the availability, this is the demand. Now we should make one more similar table, but sorry, it should be, just by the changing values of each of them. So we usually make, oh no. So we usually make something, a linear expression, or a simple linear cells, but here I'm putting a 2x2 table which can change values. This should be empty, this should be empty. All right, so I had to pause the video, but let's get back. So we have inserted these placeholders here. We can enter technically any values, and so these are the reservations we are planning to do based on the demand and the constraints. So we haven't talked about constraints yet. We have actually some of them we have talked. Now, our goal is to, again, the total reservations would be sum of these two, and then these two and these two. All right. And then we can also make a total by type. Total. And this total is the sum of these two. We can also add this one because just for completion. All right, so now once we have this, we have some here, some here, some here, some here, some here, and we can go into our function, the profit maximization function, profit, and this should be equal to the sum product. So we have this this area, so I'm not including this area, I'll do it separate. So this, we have to be careful here. We have to be very careful in terms of what we enter here. All right, why don't I just do another thing here? Just to be practical, I will do. Okay, I think this will be perfect. This one is the. This will make things much easier. All right, so we have to do here some product B5 to C6, and then let's do a product with these values. These values are right now placeholders. We will change these values, or we will update these values. And this is one part, and then another part is this value should multiply only this value. If this value wouldn't be missing here and here, I would just select the whole table and multiply with this whole table. So what we are doing, we are saying reservations into the profit. For example, 30 is per night, and 10 is the number of reservations. So it will be $300 profit in one night. So this is our formula for profit maximization. We have to be careful in this part. That's one important thing here. Now, once we have this, putting all the constraints is very easy and straightforward in Solver. Let's do Solver. We know what we have to maximize. Our objective is to change this cell and make sure it's maximizing problem by changing the values of this area. And by putting a comma, I'm saying, and this area. So this is a critical input here. We usually do select everything, but here, since this is not given, if I select whole this table, this 2x3 table, I will have some trouble. But what I did, I just selected, I can show again, I intentionally selected this area first, and then put a comma, and I'm saying, then also change this value only, not this one. And then I can add some constraints. So a very simple first constraint, that how much I can have the demand. Okay, so the demand is, so these values, these total reservations cannot go above these values. It's pretty simple. So I can do these values are less than equal to these values. Oh, I'm sorry. So these values are less than equal to these values. Does it make sense? So we are saying reservations, the total reservations in each type, in each class cannot be above the demand, or cannot be above the forecasted demand. This is, we know from here. And then another one we can do is that we cannot book more than in one type. So these values cannot be above, so they have to be less than or equal to the available. And I did the same mistake. So these values cannot be greater than these values, and that's okay. So we have two constraints, And this we will make it a simplex problem. Make sure this is check mark. And that's it. So this shows that all of them are above 0. So this shows that each of these have to be above 0. We are not going negative. So we cannot do a negative demand. We cannot have that. There's a possibility. If I don't give this, then computer can think, okay, how about there's a negative demand? And in some situations that's possible. So once we have this, we can run the solver. And once we have the solver, we can have our answers. So the answers have been updated. We got our maximum profit. And this is it. All right. Any questions on this one? So what we can do here, we can go to in each type. So we have this one Super Saver with room number type 1. This is 100. And Super Saver with room number type 2. This should be 10. This is Rental Deluxe with type 1. This is 0. And this can be 60. This has to be 50. Okay, for the solution in part A, how many residents can be accommodated in each rental class? So they're asking, since rental class can accommodate, demand is different, but we cannot accommodate all of them based on our maximization problem. So we can just accommodate this much. The forecast is much higher, so they have to just send them back. Because if we keep adding Super Savers more, there's still some room in Super Saver. There's this room of demand. So there is a possibility that 20 more reservations must have come, but we just didn't take them because it's not profitable. Demand for Super Saver was not satisfied. Okay. So they have to be turned away. So 20 of these, because we know there's a demand for 130 and we can only reserve 110. So demand for Super Saver is not satisfied. Other two have been satisfied. With a little work, an unused office area could be converted to a rental room. If the conversion cost is the same for both types of room, would you recommend converting the office to type 1 or type 2? So if we have the option to convert one office room into a room, which would we go for? Which one would we go for? Would we go for type 1, convert it into a type 1 or type 2? So this we have to know which one is more profitable. Okay, so the one which is more profitable, we should go for that. And for this, we need sensitivity analysis. So we'll go here, solve it. I'll just print all the answers. So it gives us 3 reports. I'm sorry. So we have to look into the shadow price. The shadow price for room number type 1 is 30 and room number type 2 is 20. Room type 2 is 20. So first of all, we can just enter the shadow price here. And let's first check our all the previous work so we know what we are doing. Okay. I did enter something wrong here. Okay, it should be 30, sorry. So type 1 is 30 and this should be shadow price should be 20. Okay. Now we have to know which type is better. Okay. So what this tells us, if we put a type 1 room, additional room, we will make a profit of 30. But if we put a additional room of type 2, we will make a profit of 20. This is what shadow price tells us. So convert an end-use office space to type 1. So this simply tells us that type 1 has higher shadow price. Type 1 has higher shadow price. And that's the reason we will go for converting that extra room to type 1. Could the linear programming model be modified to plan for allocation of rental demand for the next night? So can we use this model to use, can we use the same model for the next night? So this is for example, the demand and everything is for today's night. Can we apply the same thing on the next night? Yes, we can. So we can use the last night's forecasted demand. And then, so right now we have the forecast, okay? And we can predict tonight's everything. But for tomorrow, we can take yesterday's actual what happened and forecast again, okay? So in this way, we can. And once we have the demand forecast, because these in our model, this is our demand. So now if we have the demand, we can use these numbers and predict for the next night. And what we can do, we have to just change this area. So we just, for example, in this night, we get this many reservations, or we get any number of reservations, we just change this number, for example. Now, today we know how many calls we got. We can use those for the tomorrow. So our reservations will change, the demand will change. And so we can definitely predict. You can write here is that we need the okay, each rental class. Okay, so this is a solution for question number 1. And question number 2 is very similar to one of the homework questions. So I have explained this question. I think that was question number 4 or 5. This is exactly the same as this one. So I'm not going over this question. This is very much similar to one of the homework questions. Question number 3 is little different, and I can go over on this one in another video.